Hello once again, it's tubalcain, and this is tips number 524, which is part 2 of a series that I'm doing on drilling accurately spaced holes. As said in the first video, and be sure and watch the first video or none of this may make sense, but it is most difficult to produce, drill, lay out holes that are accurately spaced if you are not experienced or do not use some of the techniques that I'm going to show you. Sometimes it doesn't matter how accurate, we just want them in the ballpark. But if you want them really accurately spaced, then watch this video and study it and think about the things that I'm going to tell you. As you know, I am the YouTube master of using transfer punches and transfer screws to try to eliminate some of the errors that you might get in matching up holes. So I'm not forgetting about these techniques at all, but that is not the subject of this video. In part 1 of this two-part video series, I covered numbers 1, 2, and 3, and those are the samples that I just showed you moments ago. Today I'm going to cover numbers 4, 5, and 6. And we'll start out on the Bridgeport mill with direct layout using the dials only. That is, there'll be no need to do any bench layout. I will do it all on the milling machine, other than it helps to have a starting point. So I will have selected a point on the material, and these are just samples that I'm doing on coupons. But I will start with a corner, and in fact what I'm going to do over there at the Bridgeport is to lay out and drill 4 holes equally spaced using the dials, not the digital readout. Alright, this is coupon number 4 in the Bridgeport mill. Now I do not intend to use the digital readout. Remember, the digital readout is a relatively new invention. Well, 40 years, maybe even 50 years old, but we didn't always have digital readouts. So on this particular mill, for this number 4, I'm just going to use the dials. And these will be pretty accurate. The thing that I have to be careful of is to eliminate all backlash. Now, when I was younger and had my first job, we had Index brand milling machines. They had vernier scales along here. This is the Accurite DRO scale. That wouldn't have been on there. But there were vernier scales both on the X and the Y axis. They were extremely accurate to use. However, they were very subject to operator error, and you had to have good eyesight in order to use them. As mentioned in the earlier video, the jig boring machines had a trough along here with dial indicators and very accurately manufactured rods to do that locating. I'm going to locate it strictly with the dials here, and some of that depends again on operator skill and the amount of wear in the screws and the nuts. I'm going to arbitrarily start here where I have a little circle and a dot. Maybe you can't even see that, but that's where I'm going to make my first hole, and then I'm going to move exactly 750 thousandths this way, this way, and this way. In other words, 4 holes drilled and reamed. It is extremely important to do what I am telling you now. That is, to get into the location that you want by moving one way or the other, but then approaching the layout line without any backlash, never backing it up. Then setting the dial to 0, tightening the knurled knob there, and locking the table, and that has to be done in both the X and the Y axis. I'm not going to show all of that because there's just too much area to cover here, but I cannot emphasize enough the need to remove that backlash, or I guarantee that you will not have accurately spaced holes. Now watch me as I locate in the Y axis. I've already done the X axis. backing off, and then approaching that layout line, locking the table, and turning the dial to 0. I've already mounted a starter drill or spotting drill in the chuck. You can also use a center drill. In this case, I just decided to use a spotter drill. They are very short and stubby, will not flex because I have not center punched any holes. Then I will drill the 15/64 and then ream it 1/4 inch. I need to slow down the spindle speed for that. So let's get started here and do some drilling. I'm ready to drill hole number 2, so I will move the table 750 thousandths in the X direction, starting by unlocking the table. And there are 200 thousandths per revolution on this dial. So that's 2, 4, 6, 7, 50, and lock the table. And this is hole 2, and from now on I'm just going to show the spotting drill. I won't show the larger drill and the reaming because that is repetitious. Now for hole 3, I need to move the Y crank 750 thousandths. So I unlock, now, should you go past your line a little bit, back it way up and then approach it, and that will eliminate backlash. That's an important step. And this is hole 3 with the spotting drill. It's important that you use sharp drills that are correctly ground. If they are not correctly ground, the drill may pull off to the side. Also, let me point out that as you engage the drill into the work, move it very slowly until the hole is established so it doesn't skate off to the side, because remember, there are no center punch marks. This may be a difficult concept for you to understand, but now I'm moving in the x-axis back to where I started from. There will be backlash. So I cannot simply start turning this dial 750 thousandths because it would be inaccurate. Let me show you how to do that. I'm going to move this crank 750 thousandths now. So I'm back to the 0, but I know there's backlash. That hole would not be accurately located. So I'm going to go past that 0 mark and then come back to it. Very carefully, not to overshoot it. Lock the table, and I believe that I should now be in the 0 position. That last little step where I told myself to back it off and then approach it again is extremely important for the location to eliminate that backlash. Again, the tables is in the correct location, and I have locked it in both X and Y, and this is the final hole. Alright, all 4 holes have been reamed, and I think carefully located 750 thousandths apart, which will give me, when I have the 1/4 inch dowel pins installed, exactly 1 inch each way. So let's go over to the bench, put those pins in, and do some measuring. Question for you English majors out there, as if there's any English majors that would be watching this. Is it an anachronism for me to be doing very, very precision work and then to be using an anvil in the same video? It was my original intention to do all the measuring with an electronic micrometer like this, but because of the bulk of these, I'm not able to get all the way down to the bottom. See why? Whereas this lets me get right down to the plate. So let's see what we got here. I'm within 3 thousandths. Here, I'm within 1 thousandth, and this way, within 1 thousandth, and here within 1 thousandth. So the only one that is a little bit off is this very last one, probably, where I had to move backwards and eliminate some backlash. I'm not going to write that all down here because there's too many numbers, but you can see that this was not perfectly accurate, but it was pretty darn close. And some of that could be operator error, or it could be wear and tear in the machine, and particularly operator error probably in backing up to this one and getting the backlash out. And backlash is a big problem, as you can see. So this is a pretty good method using the dials, but it is not by any means perfect, is it? But it's approaching perfection, I guess you could say. But it would not be accurate enough for die work. That's why they use jig borers. Next, number 5, again, direct layout on the Bridgeport using the digital readout. And it'll be very similar to just what I did in the last one, only I'm using the digital readout, of course, instead of the dials. Let's go over to the Bridgeport. Alright, I'm at the Bridgeport, and I located just with a magic marker here where I'm going to start. In other words, the 0, 0 position is right there. Now let's look up at the digital readout. Digital readouts used to be outrageously expensive. Now they're quite reasonable. But here's what I'm going to do. I'm going to zero out both the X and the Y. This is the X. And I will drill number 1 hole right there at 0. Then I will move 750 thousandths in the X direction, like that. Drill that hole, and then in the Y direction, 750. Drill a hole, and then move back to 0 for hole 4. It doesn't matter if you overshoot it. We don't care 2 hoots about backlash. Because I did overshoot it, I'm backing up to 0, and that will be hole 4. I will not show that as I'm drilling. There's 2 ways of doing this. I can drill all 4 holes in this size just by moving back and forth, as I'm going to do right now, then redo it with the next size, and then redo it again with the reamer. That doesn't require so many tool changes, but it requires the movement of the work. So, you know, it's 50-50, but for the purposes of this demonstration, I'm going to go through and drill all 4 holes just with the starter bit and not show the other 2 sizes. So here's hole 1, and I'm going to speed this up. And then off camera, redo it with a 15/64 and then the 1/4 inch reamer, and I'll see you over at the bench. Alright, let's measure. I'm getting right at 1 inch there. I'm 1/1000th over there, which I don't know why. And I'm 1/1000th over there. And oh, I'm 1/1000th, 1/2,000th under. Now remember here, and that's pretty darn good. I actually expected it to be a little closer than that, and I am mildly disappointed at that. But remember also, I talked about this in the video number 1, and I told you that all dowel pins are 2/10,000ths over, although I misspoke and I said 2/1000, but it's 2/10,000ths. So that has to be considered, but I didn't consider it. But let's do it another way now. Since these are, what did I say, 750 on center, they're 1/4 inch dowels, that means there's a 1/2 inch between them, and this is a 1/2 inch dual gauge block. So we got a pretty darn good fit right there. And right there. It feels a little tighter right there. I actually have to exert 1/10 of a gram to push it in right there. And a little bit easier here. Oh, get out of there. On this end. But there's two different ways. There's a lot of other ways of measuring as well. But that was interesting, wasn't it? But if there is any error, it could have been when I engaged the drill bit in. Remember, I didn't use a center punch mark. I was using a starter drill. Could it skate or deflect a little bit? I suppose yes. And that maybe is what caused that real minor area. But remember, a human hair is 1 or 1.5 thousandths in diameter. Alright, let's measure a human hair. And I just plucked one. How I managed to get a dark one, I don't know, because they're all gray. Some of you are going to accuse me of using a dog hair. But that hair is 2.5 thousandths. A little thicker. Remember, blonde hair might be thinner. Red hair may be just a hair thinner. Oh, I'm using the term hair. Alright, I've got one of my hairs in the anvils here of this Banggood micrometer, which reads to the 1/10 of a thousandth. So my hair is 2 4/10 thousandths of an inch in diameter according to this. Why am I showing you this or talking about it? Just to show you how minute 1/1000th of an inch is, that a hair is actually over 2 thousandths thick. Alright, we're on to number 6, direct layout on the Atlas compound drill vise. I venture that only 10% of the people watching this video have a milling machine, but most of you have a drill press. So here's an alternate way of doing it, and in this case with Atlas or Craftsman brand compound drill vise. Let's talk just a little bit about that before we get started. This is the Atlas Press Company catalog from the early 50s, and here is shown the universal compound vise. I do own one of these. I really have never used it, so this is, I guess you could say, the inaugural run of it. It still has some packing grease on it. You may have watched the video where I unpacked this several years ago. And the downside of this is that the dials are absolutely tiny and hard to read, plus they are corroded on this device because it's quite old. Now there are other companies that sell similar devices, and I'll show you real quickly the Palmgren one I have, but I'm not going to use it because it's kind of heavy and bulky, but it would do the same thing. There are other work tables and things that you can buy to use on your drill press that would allow you to locate in 2 axes quite accurately, we hope, to about the 1/1000th of an inch. Alright, here it is, and I mistakenly called it a Palmgren a few minutes ago. This is a Wilton brand. I believe Palmgren does make one. It is a vise along with a 2-axis positioning system. Again, the dials are way too small, and I believe on this, I really haven't examined them until now, I believe that they are in millimeters. But at least they're satin chrome and easy to read compared to the one I'm going to show you here momentarily. For this part of the video, I'm using the Rockwell drill press along with the Atlas table here, and you can see how I've got it set up. And the vise here is kind of awkward, but it's still pretty nice, but you can see how small the dials are, and they're relatively corroded. I did clean them up, but with Scotch-Brite it didn't help a whole lot. Let me just mention one other thing about these dials. Okay, here's another Atlas dial. They're 1 inch in diameter. Now contrast that with the Bridgeport here and the diameter of these dials, and which do you think is easier to read and more accurate? Just trying to make a point here. I know this is off topic, but when I was a 16-year-old boy in high school, 100% of the drilling was done on a drill press using that Atlas table. All the layout for the holes and everything was done in that manner. We had 2 drill presses and 2 of those devices, and believe me, they were already beat up when I was there in 1959. Other than the dials, this Atlas Craftsman table is in perfect condition. This can rotate too, 360 degrees. It's a bit awkward here. These jaws have to be loosened with an Allen wrench and moved into position. I'm using 2 parallels. I'm going to start here arbitrarily where you see X marks the spot. And I've already tightened this, and then these 2 screws have to be tightened, and that too is a bit awkward. And I am clamped and bolted onto the drill press table. So now it's ready to use. I just spent the last 10 minutes trying to polish this dial a little bit and getting that screw loose, and I did succeed, so I won't have to call Bruce to do that. But you can see that the dials, no, I'm going to have to free that up. It doesn't turn. The other one does, but this one doesn't turn. Let me spray it and see what I can do with it. Well, I did get it freed, but it wasn't easy. Took 15 minutes, as a matter of fact. But it's just terribly hard to read. An alternate, of course, would be to use dial indicators, but you'd actually need 2 of them in a manner such as this, and you could very accurately locate the work. But I'm not going to do it that way. My whole plan here is to bring the work up under the drill bit, approximately on that X. Make sure again that the backlash is removed, so I'm going to approach and never back off. Then I will zero out the graduated collars and drill the first hole, move 750 in one direction, drill another, and so on, working my way around, and only with the pilot drill. Then I'm going to go over to another drill press and open up the holes with the 15/64 and do the reaming on another machine because of the difficulty of re-establishing the exact position with this type of table. So I'm really just spotting and pilot drilling. I've located the first hole. Both collars are set on 0. There's no good way to lock the table. And I'm moving 750 thousandths. And this is hole 2. And now 750 again. And this is hole 3. Now this is the hard one. I want to move 750 out and then get rid of the backlash. And then past it and back up to it to remove the backlash. We'll see how that works. And this is hole 4. And out of the vise it comes. I know many people will disagree with this, but I am going to freehand drill it 15/64, freehand ream it 1/4 inch on the other drill press, and I will not show that. For some reason, I don't have a good feeling about this at all. I'm thinking 5 thousandths or more off. Let's see what we got. Right on, actually, within 1/2 a thousandth. But look here. Oh, all right. 3 thousandths off. About 2 thousandths off. And only 1 thousandth off. I am very, very surprised at that. I did not have high hopes at all. Let me go ahead and mark those amounts, and then we'll summarize what I've done in the last video and this video. Let me review this one. I wrote down the dimensions. So that was 0.99, and the Joe block will not go in there. Good fit there. Good fit. A little sloppy. And no go on the 999. So those dimensions are really all over the place, but yet pretty darn close for a Atlas table. Let me summarize now. Number 1 was the simple layout with a combination square, and it wasn't close, but we didn't expect it to be. I didn't. With the height gauge working very accurately, it was pretty darn close. Go back and look at part 1 for these 3. And for the optical center punch, that came out just terrible. Just terrible. Could have done better with my open eyes like I did up here. And Bridgeport with the dials was about where I expected it to be, a little bit off. The digital readout was quite good, although I expected them all to be perfect. That surprised me a little bit. And then the Atlas was quite good, but not perfect. So you decide which method is best for you, depending on what equipment you have. And I hope you enjoyed this video as much as I enjoyed doing it, because this is something I really never have done. It's just a thorough comparison. And I know it's not scientific by any means, but yet I thought interesting and maybe useful for me and for my viewers. So this is tubalcain saying so long for now. See you in the next video.